Okay, hello everyone. Welcome to my first ever DroidCon talk. As you can see, this is around writing apps for the work profile. So just before we get started, a little bit about me and the company I work for. So my name is James Swinton-Bland. I'm the developer advocate for EMIR, for Zebra Technologies. For those of you who don't know Zebra Technologies, we're an Android OEM who develop task-specific devices. So those form factors that you see there, they're all running Android, and they're just built to meet different use cases. I won't go into too much depth there. We're a sponsor, and we have a booth downstairs, so if you'd like to learn more, come along, and either myself or my colleague can talk you through things. We've also got a fair bit of decent swag, so that's our little zebra mascot there called Zippy. We're giving those away, which are good for the kids or the nieces and nephews, so feel free to pop down to the booth. So in terms of writing apps for the work profile, the first thing we want to start with is just an overview of the work profile as a whole. So what is it? So the work profile was first introduced in Android Lollipop, and it's essentially just a separate sandboxed profile or user on Android devices. So this user or profile is essentially there to store all work-related apps and the associated data with those apps. So Google introduced this to enable deployment methods such as BYOD and COPE. So BYOD stands for Bring Your Own Device. So this is for companies or organizations that want their users to bring their own mobile devices into work and then use them for their work use cases, basically, and being able to keep their personal and their work data completely separate. So the user can have a personal profile with all their apps, Facebook, and so on, and then a work profile which they use when they arrive to work, and then everything is kept completely sandboxed and separate. COPE is corporately owned, personally enabled. It's pretty much the same thing as BYOD, but rather than bringing your own device, the company assign you one, and then you can take that home and use it for personal reasons. So those are two pretty big deployment methods in enterprise. And when we use it in enterprise, the work profile is then owned by what's called an EMM. So EMM stands for Enterprise Mobility Management, and it's a piece of software that essentially sits inside that work profile and acts as essentially the admin to allow you to remotely manage and provision what happens inside that work profile. So you have a separate profile that contains all of your work-related stuff, and you have an app called an EMM that sits in there that lets you control everything that happens inside that work profile. There's also a separate Play Store for work profiles. It's called Managed Play. So this differs in the sense that the organization in charge of your work profile gets to decide which apps are visible to you in that Play Store. So they have to manually go ahead and approve apps, and those apps that they've approved are what appears inside your Managed Play Store, and then the user can decide whether or not they want to download those. So now that we have at least a rudimentary understanding of what the work profile is, the next question is, should you really support it in your application? So Android used to have this tagline called Android for everyone, and I kind of agree with this. So essentially, as developers, I think we want as many people as possible to be using our applications. We don't want to turn our back on any possible areas of installation and things like that. So I think you should at least consider it, and these are the three things that you should consider. So the first thing you want to consider is, who are your users? So if you're writing an educational app for children, for example, that's obviously not going to be a viable app for a work profile. But if you do see some value, if you think your app could be used in the workplace, then you also want to consider whether that organization is then likely to approve your app for their curated Play Store. So apps which add value to standard work processes, calculator apps, calendar apps, things like that, they're obviously unlikely to be approved by the organization, but it's just worth bearing in mind because the organization has to manually approve your app before its users can use it inside the work profile. So if we've decided that this is something that we would like to support, we would like to have our app work profile compatible, the first thing we need to understand is how those apps actually end up on the device. So I alluded to this a couple of slides before, but essentially the first thing that needs to be done is an EMM, an Enterprise Mobility Management Provider, needs to be selected. So Google provide two of these essentially, Android Enterprise Essentials or Google Advanced Endpoint Management, and these are EMMs from Google themselves. But there's also a 139 Android Enterprise recommended EMM providers. So essentially, these are independent software vendors who've gone over to Google, submitted their EMM application, Google have reviewed it and said, yep, that ticks all our boxes, we'll recommend this to you. So organizations have a huge number of EMMs they can select from, 139. Once they've selected one of those EMMs, the application just needs to be installed from the Play Store. Many of those EMMs are also going to support iOS, so the things I'm talking about here are also sort of transferable to iOS, but obviously the implementation differs slightly. The end user then signs into the EMM through SSO or through a federated ID, depending on the EMM that you've chosen. And then the EMM is essentially in charge of that work profile. So the EMM runs as what's called device owner, and this gives it elevated permissions to do things on the device that standard applications wouldn't be able to do, like accessing the DPM APIs, Device Policy Manager APIs, which we'll talk about a bit more in the coming slides. So once that EMM is on there and it's essentially running as the owner of the device, the required applications are then provisioned to the user. So the organization can select one or more applications that they deem necessary or critical to work functionality, and then the EMM will force install those inside the work profile. So the user won't be able to remove them, and they will always be in there. Then the user can optionally select from the additional applications inside that curated managed Play Store. So if an organization has selected your app to be visible in their Play Store, then when the user goes on their work profile and opens the Play Store, your app will appear there. So that screenshot is just from one of my personal work devices, which has Intune as the EMM and a work profile on there. And that is the curated Play Store. So that's the list of apps my company has decided that I'm allowed to install. So now that we know how the apps get onto the device, we also need to consider configuration. So this is quite a big consideration when it comes to deploying your app inside of a work profile. So the first thing you want to consider is how you configure your app today. So for standard consumer models, you might have a settings activity or fragment, which then uses shared preferences to update its configurations and its settings. So you expose those to the user. Inside of a work profile, things need to be a little bit more constrained. You don't want necessarily to give the user full control over your application. You want the organization to be able to decide what they can and can't do. So essentially, you would need to consider whether your configurations apply to a user inside of a work environment and whether they should have access to those configurations. The second thing is what you configure in your app today. So a lot of the configurations that you probably have in your app are very consumer focused and directed straight at the user, but they don't necessarily take into consideration some of the things that organizations would want to see inside of an app. So for example, if your app does data collection for analytics purposes, enterprises might be a little bit more cautious over what apps can read that data. They might consider that data a lot more sensitive than maybe just a standard consumer. So you need to consider things like, does my app collect data that an enterprise administrator might consider proprietary? So if we've decided that there are things inside of our app that we need to change in terms of configuration, so we want to take the ability for the user to make those configurations, take that ability away and give it to the hands of the IT admin in charge of that work profile, then we need to use something called managed configurations. So managed configurations were introduced when the work profile was introduced, and this is essentially a way of you defining the things that you can configure in your app and then exposing those to an IT admin so that only they can configure it. So the first thing you would do is you define your application configurations or application restrictions inside your XML. You put a little tag inside your application manifest tag, which is the first code snippet up there. And then you reference this restrictions.xml file where you list off all your restrictions. So you can imagine if you have a preferences.xml file that has all your different preferences that you would then load in your settings fragment, you essentially do the same thing, but you create this restrictions XML so that it can be used for managed configurations. Once you've defined this XML file, you then essentially just need to monitor the state of your managed configuration. So if your app is in the background, you want to make sure when you resume to check if any of your settings have been changed by the IT admin, and then subsequently configure your app as such. If your app is running in the foreground as a service or the user's engaged with it, a broadcast is also sent whenever these managed configurations are changed on the back end by the IT admin. So essentially, you just need to define the configurations that are available in your app, hook into the broadcast to listen for changes, or use the restrictions manager API on resume to check if anything's changed, and if it has changed, then handle that configuration appropriately in your app. So on this next slide, I'm just going to give an example of Google Chrome, which has exposed a number of managed configurations. And then I'm going to show how it looks on the device next to an EMM. We're going to enable and disable certain features, and then we can see that applied to the device in real time. So on the left, we have a video of our device using Visor. So the first thing I'm going to do is just open Google Chrome and open an incognito tab. Screen goes black because the screen recorder won't record incognito mode. It's just a security thing. And then I'll go into the settings and I'll try and sign into Chrome. So we can see that both of those features are currently available on the device. Now we navigate onto the right-hand side of the screen. This is the Google EMM. We've opened up the settings for the Google Chrome app, and we can see we're scrolling down there, and now we're disabling incognito mode. We're going to do a little search, and then we're going to disable sign-in as well, and we've configured that, and then we hit save. So essentially, the EMM has taken that configuration and then pushed that down to the device, and it's been applied in real time. So now we can see the option to open a new incognito tab has been grayed out and disabled, and the same with signing into Chrome. So this is a good example of how you can use managed configurations to sort of restrict what a user can and can't do with your application inside of a work profile. Obviously, for a consumer, you're never going to want to be able to disable that, but for work profiles and for organizations, that's something that's very important. So there's some other things that we also want to consider. So the first thing is that the user may frequently disable the work profile, stopping your app. So on that first slide, we had a GIF where it was showing how you could toggle the work profile on and off. That's obviously an optional setting, but some work profiles will enable that. So you need to be aware that your app could abruptly stop at any time and no longer function. So you need to be able to handle that gracefully inside of your application. You also want to consider whether your application will be present in both the work and non-work profile. So that's because so long as your app is given the same package name and signature across both profiles, then there can be some cross-communication. A good example of this is the Google Calendar app, which synchronizes across profiles so that if you add something to your personal profile calendar, it will appear on your work profile calendar. So there may be some features in your app where it's good to have consistency across the different profiles, and that's something worth considering. The final thing, and this is a pretty large consideration, is that the behavior of the device may be locked down in unexpected ways. So I alluded to in the beginning of this presentation something called the Device Policy Manager. Essentially, this is a collection of APIs, and that screenshot is designed to be illegible just to show how many APIs there actually are. These APIs allow the EMMs to do certain things to the device that you wouldn't expect to be possible on a consumer device. So some examples of this are disabling the camera, disabling backup, location, and doing that all programmatically. So essentially, if your app relies on one of these features being present, if it relies on a camera being present in the device, you need to be aware that that functionality may be completely disabled even though the hardware is available. And that's something your app just needs to respect. So one example of this is disabling account sign-in. So in this little demo, just essentially open up Outlook or Google Maps, I should say, and try and sign in. And then when we add an account, we can see that that action is not allowed. And that's completely separate from your app. So the IT admin decides that on a device level or on a work profile level, and then your app just needs to adhere to that. I use this example here because I think maybe Google could have done a slightly better job here. We saw in the Google Chrome they actually grayed things out, so it was very intuitive. Here they let you go through the entire process before letting you know that sign-in wasn't available. So that's also something to consider in your app. You know, if certain features are disabled, maybe you don't want to take the user through that entire process. So if we've decided we want to write an app that is work profile compatible, and we've taken into consideration these different issues that may crop up, then the last thing we're going to want to do is actually test these changes inside of our app. So before you can run and test your app inside of the work profile, you need to know the ID, essentially, of the user that you're targeting. So these are two separate users, two separate Linux users on the device. And you can see there, if we run the ADB command dump sys user and have a look for the user info object, we are returned this information here. So the first line in that return is essentially the standard user that you would see. And then the second is the work profile that has been added to that device. So we can see it's given the name of sample managed profile. And then the important bit there is where it says serial number equals 10. That is the ID of that user. So if we go into Android Studio and we open up our run and debug configurations, essentially we just need to add these two flags to our build configurations. So user, and then pass through the ID that we just received from the previous slide from the ADB command. We also want to make sure that we don't just install it for that user, but we launch it for that user as well. So those are the two flags that you would need to change there. Once we've installed that app onto the work profile, we can then start to test that with the DPM, or Device Policy Manager API restrictions. So Google have kindly developed this app called Test DPC. Essentially, this gives you access or a UI front end to all the DPM APIs, and essentially lets you turn them on and off so that you can test. This is quite handy because it means that you don't have to go through the rigmarole of finding an EMM, signing up for an account with them, downloading that onto your device, and so on. This just sort of works out of the box. So once we've installed that app, we can see that it's just given us essentially every single API. It's given us a UI option to enable or disable or configure. So we can see there we can do things like setting the brightness, toggling account management, and so on and so forth. So in this next slide, I'm just going to give an example of this test DPC in action. So I have an app on here that is trying to access the location on the device, and it's going to try and request the location permission when it's launched. In the work profile, we can typically expect that the location permission will be pre-granted for us. That's because when users open apps, we don't want them dealing with accepting and denying permissions when we've already approved this app for our work profile usage. So we can assume that they're going to be pre-granted. So we can use the test DPC to toggle that pre-grant of permissions on and off. So let's see this in action. So that's me opening the app there, and it's requested the location permissions as you'd expect. I come out of that app and open up this test DPC app, and I can look for the set default permission policy or manage app permissions. I can then go ahead and select my particular app, in this case location API exerciser, and now set those to allow, and you can see the OS is prompting me to say that permission has been granted to this app by my IT admin. And now when I open up my location app, I don't need to request the permissions. They're all pre-granted for me. So that's just one example of using the test DPC in order to test these functionalities. Pre-granting of permissions is just a common one, but like I said, there's literally hundreds of these DPM APIs that you can test your app against. So these are just sort of the resources that I've drawn off for this presentation. It's only a lightning talk today, so I've tried to cover everything sort of as quickly and as briefly as I can. So you can access the test DPC on the Play Store, and they also open source the source code for you. A list to the DPM APIs, which is, like I said, a very long list, and then a YouTube playlist of the demos that you've seen here, and credit to my colleague Darren Campbell for creating all of those demos. So I don't think we have too much time for questions, pretty much coming up to the end of the 20 minutes here. If you do have any questions or there's anything you'd like to talk through, please feel free to come and find me and my colleague down at the booth, and we can talk you through it in as much detail as you like. But for the last 30 seconds or so, if anyone has a quick question, I'll be happy to answer. No worries. So thanks very much, everyone, for coming. That's pretty much the end of the talk. I'm just going to do a shameless plug for our Zebra community here before I let you all go. So please feel free to sign up to our developer portal, register for our DevBuzz newsletter, and it will keep you up to date with the developer things that we're doing here at Zebra. And finally, thank you very much for your time and coming to my talk today.